Hello everyone. So we were gonna start a new series which is very interesting. Okay, let's see why we have a multimeter. So if you see here in this multimeter or in all of the multimeters, we have these leads being connected to these bananas. We call banana inputs, if I'm not mistaken. Okay, so if you can see here we have the COM. Then here we have the amps measurements, milliamp and the 20 amp. Here we have the rest of the measurement, which is the voltage, ohms and hertz. Have you ever wondered why we have the amp and milliamp separated from the other measurements? In this series we're gonna know why. Okay. Also, if let's say you want to design your own power supply or your own power meter, also you're gonna need this. For example, let's see. For example, this is an old project that's used to supply some voltage to the output, from the input to the output, that need to be control the voltage and the currents. Okay, this one also use the same techniques as the multimeters. Same goes to here, same goes to here. Okay, so if you ever open the multimeter, you will see something like this. This is a PCB of an old multimeter. Sorry. So if you notice, this is the input of the amps. If it can focus, yes, you see this is the input of 10 amps. This is the input of the voltage, and this is the COM. You see the amp got this, what we call a current shunt resistor. Is a special component called current shunt resistor. This is what we talk about in this series. Okay. So if you see here, we have in some of projects we have these current shunt resistors. This one also here we have current shunt resistors here, but this one we have no current shunt resistor. How we can measure the current without current shunt resistor, we will see how. Okay. And also if you order any SMPS switch mode power supply, for example something like this, you will find also it can control the current and the voltage or the power of all that's been supplied to the output. Then you wonder how it can measure the voltage and the current. Also we will learn in this series. Okay. Here also we will talk about some components that's able to measure the currents also. These are the sensors or the modules. So yeah, let's start in this series, and I hope you can learn a lot of this. I'm very excited in this one. We have a lot of things to discuss about. We will try to measure the voltage, the main components of the electricity or the DC electricity or the DC quantities, which is the voltage and the current. Yes, in DC we won't touch the AC yet. AC maybe is another series. Okay, learn how to measure the voltage, how to measure the currents, and also how to feed the data to the MCU so we can process it, or we can design our own power measurement or power supply or whatever device that we want to control the voltage and the current of all. Okay. Hello there. So let's say, for example, we have an embedded system that consists of let's say we have, for sure, any embedded system has something called MCU, which is being connected to, let's say, we have display, let's say here we have LCD display being connected to the system. Then we have, let's say, this system going to control and power supply. Okay, so for sure we have, this is the switching cycle, or let's just call it the switch node power supply. Okay, and this is the output. Okay, and for sure this one needs to be grounded, this one needs to be grounded, this one needs to be grounded. Okay, and for sure this signal will be PWM, for example, to control the switch rate of this power supply. Okay, so far everything okay, but let's say, or in this, let's say in this architecture, it's just like open loop, is an open loop control. So this open loop controls mean the MCU will be set. Let's say we have also like a keypad here. Seven, 8, 9, etc. So this keypad also being connected to the MCU. So let's say from the keypad we key in, where's the pointer? So then keypad we key in, let's say we want 12 volts, 1, 2, key in, then the MCU will send some PWM signal. So it's not the PWM signal like this, PWM signal, okay, to the SMPS, then the SMPS will say, oh, okay, this one's been 12 volts, then we'll boom, supply you 12 volts at the output. Okay, this one I'll go open loop because it's only one way from keypad, let's say, to MCU. Let's choose another color. Let's say, can we change the color? Okay, nice. Okay, let's say this one. So this is, we say, is open loop because only from the keypad to MCU to the power supply to the output. Okay, this one called open loop. But how if we want to go further in our design or in the embedded system design, and we want to, how to bring this up? Sorry, I'm new to this MS whiteboard, so I'm not sure how to bring it up. I just need to select this, I believe. Yes, here we go. Okay, so this is the loop. But then now, let's say you want to improve your design and you say, okay, I want to have a closed loop, or before we go to directly to closed loop, by mean of I need to exactly control our output, or I need to monitor our output. For example, if previously when I set 12 volts at the output here, is it really 12 volt or no? Could be like 12.5, could be 11, could be anything. Okay, so how to design that? Then we say we still have the same MCU. Let's say here we have our LCD. Let's say the LCD will be in which color? Just now. Okay, here, oopsie, apply here. Let me say right. Okay, so here we have our LCD. Then we have here our MCU. Again, same thing, go to our SMPS, which switch mode power supply. This is P, SMPS, okay? And here, let's say we have our input, which is our keypad. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? This is the keypad to the MCU. And this one is, let's say, the signal for the LCD. Okay, so now let's say, so we have from here we have the output. Okay, to make our system more precise, or to make it perfectly outputting whatever we want or we ask it to output, we need something at the output to monitor the output. We have some sensors here to monitor the output and feedback to our MCU. Let me choose another color to make it nicer. Which color to choose? Let's say green color. So we have another block called sensors that feedback to our MCU. Okay, so now we have what we call a closed loop. So this is the closed loop system or control system. Okay, so this system will do what? First, again, from the keypad, it will send signal to the MCU. For example, oh, I need 12 volts. Okay, then the MCU will be outputting, okay, submit 12 volts to the SMPS. Then the SMPS will say, okay, here is our 12 volts. At the same time, whenever the output is outputting the 12 volts, this is our 12 volt, the sensor will measure whatever quantity need. For example, here, let's say we are at the constant voltage mode, let's say. So it means whenever we ask it to output 12 volts, so the sensor needs to monitor the output. Let's draw the output here. Which color? Let's say the output in blue. Okay, we ask it to output this 12 volts. Okay, so after the SMPS output our 12 volt, the sensor will keep monitoring this 12 volt and feed back to the MCU. Okay, so if the feedback is, let's say, more than 12 volt, let's say 13 volt, or less than 12 volt, let's say 11 volt, then the MCU will do the necessary things by adjusting the PWM, okay, to maintain the 12 volts at the output. Okay, so this thing what we call closed loop system, which closed loop system can be simplified or drawn as the follow. We have here as the control. This is the control. Sorry, let me make it nicer or smaller. Here we have control. Okay, then we have our output, or before the output, let's say we have our system, or we have our SM. Here actually is the SMPS, or the power the switch mode power supply that we are controlling it, but let's call it is our plant, which is outputting our voltage. Okay, it's exactly, yes, let's put it like this. Okay, so control, which is here represented by the MCU. We have the plant, which is this one, the switch mode power supply that we are controlling it. Then we have the output, which is our output, or which is the whatever is outputting voltage or current, depends on the mode we are working on. Okay, and for sure we not forgot we have our input here. This is our input. So again, this input is actually here, which is representing our keypad. Okay, then we have something called feedback. So this is our feedback. Okay, so we have here, we have two signals, one from the feedback, okay, from the output we feedback to the system, and one from the input. Okay, so these two we are going to sum it and enter into the, or supply it to the system, to the control system. Okay, sum it, this one will be always positive, this one, since the feedback will be negative, we'll sum it and enter this. Well, for sure, if we compare it with our previous system, let's see if we can, yes, make it smaller a bit. There we go. So exactly here we can see the comparison of what we are doing. Can I close this? Okay, no, it's okay. Let's make it more smaller. So open this guy, more smaller. Can I bring it up a bit? Okay, nicer. So we can see here we have our input here. That doesn't work. Okay, our input. Hello. Input. Okay, our input, which is representing our keypad here just now. Control system, which is our MCU. Plant, which is our SMPS, switch mode pulse, or any circuit we want to control. Output, which is this our output. Okay. Feedback system, which is representing our sensors. Okay. This sensor could measure any quantity or whatever quantity we want to control. Then we feedback to our system, which is same what we are doing here. Okay. Then we found the difference between them, supply to the control, so the control know what to supply to the plant to control the output. Okay. For example, in this example, we are using the PWM. Okay. So now, and for sure, we won't talk about more details about this this topic. This tutorial, I'm gonna focus on the feedback or the sensor parts. So this topic is very complicated and got a lot of things to cover. But if you guys want me to cover this, for sure, I'll try to do more in the future. But so far, I'm focusing on the sensor parts, on the feedback. Okay. So since we talk about the sensors and feedback of SMPS, so let's see. Let's go back to normal. Let's go to 900. Okay, 100. Okay, so since we talk about the SMPS, so usually for the SMPS or switch mode power supply, usually we have main two quantities to control, either the voltage or the V out or the current I out. Okay, these are the main quantity we need to control and monitor. Okay, the voltage and the current. The other quantities we can just drive it from these two. Let's say if you want to measure the power, what else you need? Okay, let's say the power, as long as you have the voltage and the current, just multiply them, you found the power. For example, if you want to see the power that you're outputting. Okay, but these two are the most important things that you want to monitor. Okay, so now let's start. Let's say how to measure the voltage. Okay, let's say how to measure the V out. V out is very straightforward, very easy, and directly can be applied to the control system. Why? Because all the embedded system or the MCUs we're using able to detect the changes in voltage. Okay, it's very straightforward for them to detect the the changes in voltage is why. Who knows why? Yes, I guess most of you guys know why. And see you. Why? Because we have some very, very powerful component called ADC, analog to digital converter. Okay, this analog to digital converter can detect the in the input signal. Okay, let's say you have a signal, it's changing from, let's say this is the 0, let's say enter here 5 volts. Let's say it's vary from 5 volt, go down, let's say go up, go down, go up, go down. Okay, this guy here able to detect and read all these changes. Okay, but got limitation here. The limitation is should be the value of the signal should be between the 0 and 5 volts only. Cannot detect less than 0 or more than 5 volts. Why? Because our MCU support or being supplied of 5 volts VCC and tied to 0 ground. Okay, so our ADC, our friend called ADC here, can support the difference in the input between the 5 volt to the ground only. Cannot detect more than 5 or less than ground or less than 0, which is okay. This is the thing. That's why if you see a lot of examples online, or not even online, let's say for example in Arduino, if they want to show you or the demo to you how to use the ADC, let's see if we try use this. Yeah, if they demo to you to use the ADC, they will ask you to do the following. They ask you to bring the what they call potentiometer, connect this to VCC, and this one connected to the ground. Okay, and this one they will ask you to, let's put it in a red color more. This one they ask you to connect it to one of the ADC channels. Okay, so by default, when you connect it to VCC, it means you put this one to, or you set the top or the maximum voltage to 5 volts. When you would connect this to the ground, it means you set the minimum point or the less point of the signal to 0 volts by default. Okay, so you already satisfy, put it like this. So you already satisfy this condition when you connect it like this. Okay, you already satisfy the condition of VCC 5 volt, ground 0 volt. So any signal in between, okay, it's be easy for the ADC to be detected. Any signal in between 5 to 0 volt is okay for the ADC to be detected. Okay, that's easy. So now the wiper, if it's moved all the way to the top, which is near to the 5 volts, so it will measure 5 volt to the ADC, it's able to measure it, or the wiper go all the way down to the 0, so that will be supplied at 0 volts at the ADC, also able to measure it. Okay, so this is how easy it can be. Implement voltage measurements. So if we come down here, if you remember, we talked about the voltage measurement of this system. So by meaning of, I need just a signal, a direct signal. Let me take a pen, let's say this one. So I can take a direct signal, I tap the output, then I can supply to the ADC channel directly.
But be careful. I need to make sure that the maximum output should not exceed 5 volts and the minimum should not be less than 0 volts. I can do this directly, tap the output, supply to the ADC with no harm. But again, I should make sure I follow this condition, the minimum and the maximum. Okay, I should make sure I fulfill this criteria.
Okay, so
okay, guys,
this is the connection, okay, or the main connection of the circuit, or the, let's say, the voltage sensor, I can say. So this circuit here is the voltage sensor. Voltage sensor. Okay, this is how it works, but we will have an issue. Just now we say this is the circuit if our output is from 5 to 0 volt only. But how if our output is more than this? Okay, especially if the voltage is more than 5 volts, what we're gonna do? Let's say we go down. Let's say here, because we need our ADC, so I don't need to draw another MCU. Let's say how if our output is from 0, let's say, to 24 volt DC. How if the output is in this range? Okay, what you're gonna do, because our ADC can support 5 volt maximum, as we said just now. Okay, this one also is easy to be settled by using something called, exactly, you guys guess it, something called voltage divider. Okay, just use a voltage divider at the output, then your MCU will be protected. How to do the voltage divider? Good question. So we take from your output, okay, from your output, let's say, okay, it's better to draw another one. Yes, voltage divider, let's put it here. Take this one, black color, or no need. Okay, let's say again, here our MCU. Our MCU is being connected to VCC 5 volt and being connected to the ground. Voltage divider, we say we need it if our output, let's draw the output, if our output more than 5 volts. So this is 0, this is 24 volts. We said we can use a voltage divider. So let's say from our MCU, go all the way to our, let's draw the SMPS in black, so it's considered like an block or system. This is switch mode power supply. Okay, so this is our output, this is the out. Okay, how are we going to solve this issue? We cannot directly take a signal from here to our ADC. Let's say here we have our friend called a analog to digital converter.
Oops, shouldn't be like this. No. Yep, this is our ADC. We cannot directly take signal from here to our ADC and say, okay, enjoy. Cannot. Why? Because our voltage is more than 5 volt. What we said, use voltage divider to solve this issue. How to use it? Okay, we take the signal from here, we supply to 2 resistors, 1, 2, to the ground. Okay, we call the first one is R1 and the second one is R2. Okay, then the middle point is safe to be taken to the ADC. That's all. This is our voltage divider. Take 2 resistors, R1, R2, in series. We feed them from the V out of our SMPS or whatever source of the voltage that we want to measure. The second end will be connected to the ground, and the middle one will be connected to our ADC. That's all. But again, it's not just like 2 resistors, not any random 2 resistors. There is a equation to calculate these 2 resistors. Okay, so these 2 resistors will be, let's use green color. These 2 resistors, there's a calculation to find the value of these resistors. Okay, to calculate, calculate these 2 resistors to find the V out. V out here, because here we already use the V out here. I don't want to name this line as a V out. I will name this as VADC, VADC. Okay, how to calculate the VADC? So the VADC equal to what? The V out here, because this V out is being supplied to here, the voltage at this point, which is the V out. V out multiply by what? By R2 divided to R1 plus R2. That's all. Very easy equation. Okay, to find the ADC, which is this signal that's been supplied to the MCU, we need to find the maximum value this SMPS can supply. What's the maximum value? Okay, 24. So this 24 can come here. Then we just put R2 multiplied by R2 divided by R1 plus R2. That's all. Okay. Now, these two, we have 2 variables here, R1, R2. 2 variables are not available. So we can assume one to calculate the other. Okay, because now the V out is equal to 24. Okay, this is good. But how about R1, R2? This is kind of cannot be solved actually without assuming one, find the other. So how to assume one, find the other? Usually we can start with very, very high value for, let's say, R2 or R1. We can take very high value, let's say. Why take very high value? Let's say if we take low value, let's say 0.5K at here. Here also might be, let's say, 1K. So 0.5, 1K, this load, the overall load between the output to the ground will be very low. Okay, the load, the resistor, let me choose, let's say, this purple, okay? So the load or the overall, let's say just now let's say 0.5 here. Here for this resistor, let's say 0.5K. And this one, let's say 1K, 1 kilo ohm. So the overall resistor between this point to the ground is 1.5. Because they are in series, isn't it? Series 1.5K. 1.5K kind of consider low resistor at the output, especially if your output is 24. Okay, so when low resistor, there will be a high current going to the ground, which is wasted. So these resistors will be very hot. Okay, and your system will be not efficient because of the high current. This is the high current will go to the ground, so the output won't be 24, might be 20 or even less, maybe 19 volts. So this is not efficient system. So we need to choose the resistors very high, let's say 10K or 20 or even 50K. Usually I will choose, let's say 50K, then I calculate that maybe become like 20K. Something like this. It's very high value. Why? Because let's say 20 by 50K, it will be around like 70K. I mean, if they are, because they are in series, if you calculate it, 50, 20 or 25, it will be like 70K kind of high value. So the current will not be, actually at the end of the day, it's just ohm law. You can calculate it and find that the current flow through these 2 points will be very less. So the output will be very efficient and these resistors won't be hot anymore. Anyway, this is not our topic, but this is how you can do if you, because in this series I want to focus on the current calculation, or sorry, current detection or current sensor, I can say, current sensing method. So voltage not into my consideration, but if you guys interesting more on this calculation, please let me know. I'll try to make another tutorial on it. Okay, but this is how you can do. The only thing I can say, be careful when you choose the resistors and be careful when you supply directly your output signal to the MCU, or you need a voltage divider that bends your maximum output from the system. Okay, guys? So we have done for the voltage measurements. Now we can move on to the currents. Okay, so far we have done with the voltage measurements. Let's talk about the other quantity, which is the current measurements. Let's go up. Let's go up. Draw our circuit again. Say here we have our MCU, which is connected to VCC and ground. This is the VCC. Okay. We have PWM go to SMPS, switch mode power supply. Okay, and here we have our output. It is red for the output. Let's say our output is like this. Okay. Let's change so the output from 0, let's say, to 24 volts. And this, since it's 0 to 24 volt, I cannot directly take one signal to our ADC. Let's try our ADC here. This is the A. Nope, this is not A. This is the ADC. Oops. Why? Need to click here. Click here again. Okay. This is the ADC. Since our output is, this is the output from 0 to 24, so we cannot directly take from the output directly to the ADC. This is for the voltage. We still talk about the voltage measurement. So, oops, redo. We need to add a circuit, which is we talked previously. We talk about it. Let's say resistor is another resistor, go to ground. Now we can take one signal from here to our friend ADC. Now, okay, this is the voltage divider to measure the voltage. Okay, so I can say here, this is the voltage sensor. Now I want to measure the currents. Now I want to measure the current. Let's say here, this is the output. Let's put it into here. Now I want to measure the current. How? For sure here, because the voltage, as we all know, is very standard and basic. If you want to measure the voltage, you need to connect your measurement tool in parallel with the source, because this is the source of our measurement. So this one will be in parallel. Okay, so this is the source, this is the one, they are in parallel. If you want to measure the current, the meter or the ammeter need to be where? In series. Okay, now before that, let's say we have load here. Here we have load to the ground. This is L, our load. Okay, so the measurements need to be in series with the load, either from the high side or from the low side. This one called high side, this is called low side. Okay, this will for sure we'll talk about it later, because it's got different readings, different places got different readings. Okay, this is one thing. Another thing is our MCU cannot measure the currents directly that flow into the wires, because at the end of the day, these are just wires or traces on the BCP. So our MCU got no functionality to measure the changes of the electrons that pass through the trace or any conductor, because if you want to identify or define the currents that flow through a wire, it's just electrons that's been flow through the wire from one end to the another, or from, let's say, source to the ground through the load. Okay, the MCU doesn't have this the ability to do so. So what we can do, this is what we will focus on, because it's an issue, not an issue, but is a not easy thing, I can say, not straightforward approach to be implemented. That's why I was thinking that this is the good tutorial to be made for you guys. Okay, so how to measure, I will give you very rough and very like high level explanation how to measure it. Actually, there are many ways to do it, but I'll tell you the easiest way and the more straightforward one is to add a resistor in series with the load. This is our load. We will add a resistor in series with the load. Let's say I will use a high side. Okay, so here I will add, let's use this one. So I will add a resistor. Okay, this one called current shunt resistor. This resistor called, let's use which color, it's black. This one, current shunt resistor. This resistor will be in series with the load. If you see, it's in series with the load, go to the ground. So it's in series. Another thing should be very, very, very low in an ohm. Okay, so it should be very low resistance. For example, here might be like 1 ohm or even 0.5 ohm. Okay, the resistor should be very low. Why it should be very low? So it won't affect the current flow. Remember previously we say, if we go down, I told you if the value of the resistor will be very low or kind of low, the current flow through from the output to the ground will be very high. Why? Because this resistor will consider as a load, because they are in series directly from the output to the ground. Same goes to here. This one, if is very high in value, if this one is very high in value, so it will consider like another load in addition to this load, which is wrong. So the value should be very, very, very low and small, so it won't be affected. It won't affect the current that pass through it to the load. Very low, so it won't disturb the current that pass through it to the load. Okay, this is one thing. Another thing, it should be very high power. Let's say, I don't know, 10 watt, 20 watt. Okay, should be very high power. Why? Because although is very low in resistance, still got resistance, say 1 ohm or 0.5, still got like some small resistance that will be turned into a heat. Okay, so this will be turned into heat, so it will be consuming some currents. This can again turn into a heat again, and heat, more current, heat, current, blah blah blah. So this one should be very high power, so it can handle the current pass through it. Okay, then when we have a resistor, what we can do again is Ohm law. These all things will be discussed in details in the following parts of the tutorial, but again, this is a very rough idea just for you guys to understand what's going on. Since we have resistor in series with a load with very low resistance, we can directly come here, my friend. We can directly, or before we can directly, let me ask you guys, what do you think? What will happen if we have resistor that with the current being flow through the resistor? What will happen? Yes, for sure, there will be a voltage drop. There will be a voltage drop on the resistor. So let's say if you put, we have no space, damn it. Okay, let's say if we take this wire, we connect it to a voltmeter, we can measure the voltage drop at this resistor. Okay, equal to X volt. Okay, so with the voltage at this resistor, and we know the value of the resistor, boom, we can find the current that pass through this resistor. And since we know the current I that pass through this resistor, then we know the IL or the I load or the current. Why? Because they are in series. Again, since they are in series, the currents will be same. I1 equal to I2, isn't it? So the I here equal to I here, because we have the voltage drop at this resistor. We know the value of the resistor. We can calculate the current, Ohm law, then done. Since we have a resistor here, and we need to measure the currents on the terminal of this, we need to measure the voltage at the terminal of this resistor, then done. We convert it to a voltage. Now, this voltage can be directly sent to the ADC. Because it's voltage at the end of the day, ADC, it's very professional in measuring difference in voltage. Then done. Since we able to measure the voltage, then the ADC can just calculate the current based on the value of the resistor. That's all. We found the currents, but got some issue. The value here we need to find, because here we have the 2 points. This is point, another point is here. So not only 1 point. So how to measure these two? Either you need to take like 2 channels, like one from here, one from here, or we can use differential amplifier, take one. This is one solution. Or we can take out this, put it at the low side. So at this one is already grounded, so no need to take it, take only from the high side. So all this headache will be discussed in the following parts, but this is the overall high level explanation how to measure the voltage, which is very straightforward, and how to measure the currents. But for sure, the current not that easy again. It looks easy for you now just to give you a high level explanation, but this is what we're gonna discuss in further details in the next parts. Okay, so stay tuned for the next part of the current measurements, and I hope you have learned something from this small, hopefully short introduction. I don't want to make it too long for you guys, so you won't be bored. And yeah, stay tuned for the next part. Please let me know if you need any further explanation or anything I have missed. Do let me know. Okay, let's go. Okay, guys, so just before we close the first session of this tutorial, okay, we just need to mention, or forgot to mention, that I want to link to you about the multimeter. Okay, we were here. That's why I'll try to put the multimeter picture somewhere here. Let me choose the color black. That's why in most of the multimeters you'll find like one range for the voltmeter, okay, which is this. This is the force sensor. Sorry, this is the volt sensors, okay, which go directly to the MCU. Sometimes, especially if it's not the auto range one, you got multiple range, let's say from 0 to 2 volt, then 2 to 20 volt, and 200 volt, etc. So that's mean when you change the selector, let's say this is your selector, okay, why like this? Okay, so let's say this is your selector. Let's say this is the 2 range, 20 volt, and let's say 200. Okay, so all this is mean this one has been already set to 2 volt. This means this range has been already calculated to 2 volt. This one has been calculated to convert the 20 volt maximum into 0 to 5 volts. Same goes to the 100, etc. Okay, but the auto range one for sure got the what they call the, for sure have some differential amplifier inside that can be auto set the gain. Okay, so it can set the output to the ADC. Okay, then this one all, if you notice, this all is the volt, which is all go to a one jack, banana jack, and another one, let's say this is for M, got like say M and milliamp, sometime got microamp. Why this micro like this? Let's change to a nicer micro amp. Okay, this one for the micro amp go another banana like this. Okay, so now when we change to another place to measure the amp, is mean internally, as we will see later, it will include this current shunt resistor to detect the current. Okay, it's not standard like the voltage. That's why we have a voltage, banana, jack, and current one. Okay, so we will see this more obvious in the next sessions. Okay, so just wanna explain to you and wanna add on this at the end of the video. Okay, we can close now.